PreAP, PreCalculus, Notes 1.5, Discontinuities, and the graphs of piecewise defined functions. We are first going to talk about limits. This is an extremely important concept. It's a fundamental concept in calculus, and since this is pre-calculus, it's logical that we discuss this now. And consider yourself fortunate that we are discussing this in the very first chapter. Limits. A one-sided limit is the y value that a function approaches from either the left or the right side of a given x value. That's a one-sided limit. A limit, also known as a two-sided limit, is the y value that a function approaches it's an important word, approaches, at a given x value if the left-sided limit is equal to the right-sided limit. It's extremely important. Let's look at some pictures and see if we can make sense of what this limit thing is. Well, first of all, let's focus on the two-sided limit. This is a two-sided limit. Here's how this is read. The limit of f of x as x approaches -3 is, here's what it means. If you get closer to -3 from the left and the right on this graph, what is the y value getting closer and closer to? It's getting closer and closer to the y value of 4. Not to be confused with this question. This question is, if x is -3, what is the y value? When x is -3, y is 4. Now those happen to be the same answers, but they don't have to be the same answers. Once again, difference between these two questions. This is asking what is y. This is asking what is y getting closer to. Check out this next picture. The only thing different is instead of this being a closed dot at the maximum, it's an open circle. So what is the y value when f is -3? Well, it's undefined. It doesn't exist. On this graph, when the x value is -3, there is no y value, it's missing. This is a different question. It is read, what is the limit of f of x as x approaches -3? What it means is, as you get closer to -3 from the left and the right, what is y getting closer to? Well, these are both getting closer and closer to the y value of 4. So the limit is 4. This next one, traditional question, what is the y value when x is -3? Well, when x is -3, the y value is -2. Different question. As x gets closer to -3, what is y getting closer to? In both cases, from the left and the right, it's getting closer to 4. Since they're getting both closer to the same number, then the limit exists, it's getting closer to 4. Next question. What is f of -3? Well, when x is -3, the y value here is -2. We could go up, but there's an open circle. Down, it's a closed circle. The closed circle is where the actual y value is. So it's -2. As you approach -3 from the left, y is getting closer to 4. As you approach from the right, y is getting closer to -2. Those are two different y values. Therefore, the limit does not exist. Last picture. What is the y value when x is -3? It is 1. What is y approaching as x approaches -3? If you approach from the left, it's approaching 4. If you approach from the right, it's approaching -2. Those are different numbers. Therefore, the limit does not exist. Let's go over this definition again. A limit is the y value that a function approaches at a given x value, and the given x value would be -3 in each of these problems, if the left-sided limit is equal to the right-sided limit. Let's check out this other picture. Now, this right here is different than the previous problems that we did. This is saying, find the limit of f of x as x approaches -2. This little negative here means from the left. This next question is similar, but it says x approaches -2 from the right. A little sign, superscript to the right of a number, means from the left or from the right. So these are one-sided limits, all these ones right here. Let's check this out. Let me read this to you and I'll tell you what it means. It says, find the limit of f of x as x approaches -2 from the left. What it means is, as you get closer and closer to -2 from the left, what is y getting closer to? Well, it's getting closer to the y value of 1. This is saying, what does y approach as x approaches -2 from the right? Here's -2. If you approach from the right, the y is getting closer and closer to -2. Now, when it comes time to answer this question, we don't need the graph if we've already answered these left and right-sided limits. Limit existence theorem, which we haven't had yet. A limit is the y value that a function approaches as long as the left and right-sided limits agree. So if you look at here, from the left, it's approaching 1. From the right, it's approaching -2. Therefore, the two-sided limit does not exist because they are different numbers. And then finally, these were what is y approaching. This is asking, what is the y value when x is -2? When x is -2, the y value is 1. Next, we're going to approach 0 from the left, the right, from both sides. If we approach 0 from the left, what's y getting closer to? Getting closer to -2. If we approach -2 from the right, y is getting closer to -2. What's the two-sided limit? Well, if you approach from the left and from the right, they're both approaching the same y value of -2. You can find that without the graph just by looking at these two left and right-sided limits. What is f of 0? F of 0 is -2. This is asking what is the y value. Now, for this particular problem, the limits and the y value are the same. For the previous problem, not the same. C. Now we're going to approach 1 from the left, the right, and from both sides. As we approach 1 from the left, y is getting closer and closer to a y value of 1. If we approach 1 from the right, the y value is getting closer to 1 as well. The two-sided limit is therefore 1 because the left and right-sided limits agree with each other. What is the actual y value when x is 1? It's down here at -2. D. As x approaches 3 from the left, here's 3, as you approach from the left, what's y getting closer to? It's getting closer to 5. If you approach 3 from the right, what is y getting closer to? It's also getting closer to 5. Since the left and right-sided limits agree, the two-sided limit exists. The final question is, what is the actual y value when x is 3? Well, it's 5. Finished. Part 2. Decide if each statement is true or false. So let's check this out. This claims that for function g, which is this graph here, as x approaches -1 from the left and the right, the y value is approaching 1. So the problem is, this is false. If you approach from the right of -1, it's approaching 1, but you can't approach from the left because there's no graph over there. So that is false. How about as we approach 0 from the left and the right? If you approach 0 from the left and from the right, it's approaching 0 in both cases, so we would say that's a true statement. This one says the limit as x approaches 1 is 2. If you approach 1 from the left, it's 1. If you approach 1 from the right, it's 2. Those are different numbers. That is a false statement. Well, what about when you approach 3? If you approach 3 from the left, you're approaching 2, and there's no way to approach it from the right. So this is a false statement. The answer is not 2. What's the limit of g of x as x approaches positive 2? It's claiming that the answer is 2. Let's see. If we approach 2 from the left, y is getting closer to 2. If we approach 2 from the right, y is also approaching 2. That's a true statement. As x approaches 1, y is approaching 1. If you approach from the left, it's 1. If you approach from the right, it's 2. I disagree. That's a false statement. The limit of g of x as x approaches 1 doesn't exist. I agree with that. If you approach from the left, it's 1. If you approach from the right, it's 2. They're different things, therefore it doesn't exist. That's true. The limit of g of x as x approaches 3 does not exist. Also agree with that. If you approach from the left, it's 2. If you approach from the right, you can't. There's no graph, so that limit does not exist. That's part 1 of the notes, and that's just defining what a limit is and looking at limit notation.